So another Queen's graduate, so no stranger to Queen's, we have Anna McCartan up next, who now works for KPMG as a data scientist in the applied innovation team, or intelligence team, sorry, as well. So,
Thank you.
Great, thank you. Over to you, Anna. Thanks.
Hi everyone, it's really good to be here today. It's great to see so many faces. My name's Anna McCartan, so I am a data scientist within KPMG's Applied Intelligence team here in Belfast, so I'm sure you've seen there's quite a few of us talking today. Hopefully you're not sick of us yet. Myself and Lucy even have matching sweater vests, so that was unintentional. But yeah, so I graduated from Queen's. My background is in applied maths and physics, and then I got a graduate job at KPMG, and I've been there for almost 2 years now. And today I'm just going to give you kind of like an introductory overview of data pipelines. So firstly, I'm just going to talk a little bit about what is a data pipeline, what they're used for. I'm going to mention the two most common types of data pipelines, talk a little about them. And then I'm going to talk about some best practices. I'm just going to go over a few that have been particularly useful to me and my projects that I've worked on. And then I'm just going to wrap up a bit about why we should use them and the benefits. So firstly, what is a data pipeline? I'm going to explain it kind of in layman's terms here and use a water analogy. So if you think back at the start of civilization when people needed to get water, they probably had to trek to some well, pick up water, take it back to their home, use it for their cooking, cleaning, whatever. It was probably a very tedious process. But, you know, as civilization has evolved, the human race has evolved, so did our water needs. And now we want water at the drop of a tap. So now we have these more advanced water pipelines. My roommate's actually a water engineer, so she'll probably not love the simplicity of this diagram. But anyway, nowadays we have these complex water pipelines. So we get our water from the source, which could be a reservoir, whatever. Then it goes through this whole treatment processing process. So here the water is cleaned, you know, it's treated. Everything within this step is to make it usable for us at home to be able to drink or use it for whatever it needs to be, agricultural, production, anything. That's basically the exact same as a data pipeline, except data instead of water. So back many years ago, I'm sure people could have spent hours and hours on Excel just to generate a simple report. They maybe had dozens of data sets saved right on their hard drive that they had to manually process, which again would have been very tedious, and I'm glad I don't have to do that. But nowadays we have data pipelines, and because our technology has evolved so much, and especially big data is so prevalent now, like the demand for data is huge, so we need data pipelines that can automate this process for us. So a data pipeline is a method which moves and transforms raw data from various sources, takes it through a whole processing workflow, and then it's spat out to a final destination for storage or analysis. So again, on my very simple diagram here, I'm definitely not an artist, but you can see the three key steps are source, data flow, and destination. So the source is where the raw data is ingested from. This can be anything from website data, mobile device data, data that comes from any Internet of Things devices, databases, sensor data, so many different sources. Then the data goes through the data workflow, which is basically the step where the data is processed to make it into a clean, readable, refined format for the end user. So within this data workflow step, this involves things like cleaning the data, so maybe getting rid of missing values, deduplicating the data. It could be, you know, standardization. You could be merging multiple different data sources together. So you want to make sure they're all in the same format. You can merge them easily. Making sure things like column types, data types, everything like that is as it should be for the final destination. And then it reaches its final destination. This could be a data lake, data warehouse, anything like that for the end user. So who is the end user, or what are data pipelines used for? So the first one I'm going to mention is machine learning systems. So data science is really popular today, and especially machine learning systems. And I don't know if you know this, but you use machine learning every single day. You know, whether it's Netflix recommending you what show you should watch, Amazon suggesting what products you should buy, or even using, you know, Siri and Alexa every day, you know, playing music, everything like that. But in order to build these machine learning models, they need good quality data that isn't riddled with inaccuracies to make them as accurate as possible. It's the same for analytics platforms, business intelligence platforms, or any kind of reporting really. They all have the same thing. You don't want to be having a live dashboard, data flying in, it's in the wrong format, it's filled with errors, that's just going to break everything and be a bit of a disaster. So data pipelines really just help automate this process and provide that clean, refined data for data scientists, ML engineers, everyone like that. I'm going to touch now on the two most common types of data pipelines, which are batch processing pipelines and streaming processing pipelines. So first I'm going to talk a little bit about batch, and apologies if it's overkill in the water analogies, but if you think of batch processing pipelines as you're filling a bath, I don't know why you're using a bucket to fill your bath, but imagine you're filling up a bucket, using it to fill your bath, and you're doing that over and over again. So that's batch processing. It runs periodically or recurringly. It's usually done on a schedule. So it's quite high latency, which just means that there can be a lot of delays. And it processes large batches of data over time. So like I said, they're not very time efficient at all. They can take from hours to days, especially depending on the complexity of the pipeline and how complex the data processing requirements are. This is used in cases where the information is not very time sensitive. So things like customer orders, or maybe an electric company wants to analyse their customer usage of electricity, so they can send them a bill at the end of the month. I mean, it doesn't make sense to do that continuously. Once a month is enough. And then with streaming processing, another water analogy, it's just a running tap. The water is coming out continuously. That's the same with the data. So it runs continuously or in real time. So the data is processed piece by piece as it comes in. So it's a lot lower latency, and it processes micro batches of data at once. So it's a lot more time efficient. It takes from milliseconds to seconds. And this is used for use cases where the data or the information needed is very time sensitive. So maybe a machine learning model for detecting fraudulent claims in an insurance company, or cybersecurity. You don't want to be telling a client, oh yeah, a cyber attack happened a week ago, but it's too late now, So basically any use cases where it's really time sensitive. Next, I'm going to talk about a couple of best practices. There's a lot more I could mention, but these are kind of ones that I have found the most useful in my own role and that have meant the most to me. So the first one I'm going to mention is to create generic pipelines. And by this I mean is just make sure you're not hard coding any specific values into your code. You don't want to have specific database links or values. You want to parameterize all those values. And this just means that if you're building a pipeline for one team, another team could have a very similar business ask, and you can just repurpose and reuse that pipeline for the new team. And it could be as simple as change a couple of parameters and Bob's your uncle, you're on your way. The second one is using a modular design. So by this I just mean breaking the pipeline down into smaller reusable modules, or breaking it down into sections depending on each step of the pipeline. This means that your data pipeline will be a lot easier to test and maintain. So if you need to maybe implement any changes, you can just implement those changes on the one specific module that you need, rather than affecting the entire pipeline. And having a modular design also means that any other developers who want to see how your pipeline works, look at the design or workflow, will be a lot easier to understand and a lot more readable. The third one is monitoring and logging. So I know reading through log files is like the most boring thing ever. No one likes doing it, but if someone does, I'm not judging, but hopefully not. But it's so boring. But if anything goes wrong, there's a bug, the log files are then your best friend, because you're able to see exactly where did the problem arise, what steps have already happened. So the more you have logged, the better. Even logging the size, the shapes of your data frames, each step in the pipeline. With logging, I'd say it's always better to log more rather than less if you're unsure, and it just means you will be able to resolve issues a lot quicker. The fourth one is version control. So after Lucy's talk, I think we all know the importance of that. Even things like Git, it just means you can keep track of the changes to the code and configuration of your pipeline. If any big bugs happen or your pipeline is down, like Lucy made an example of, you can just then revert back to a previous version and prevent downtime of your pipeline. And also it means you can work collaboratively with other data scientists, and just makes everything a lot easier. And the last one is optimization. So here I'm just talking about maybe if you're coding, making sure that your code is efficient to handle much maybe larger data frames than you're using, just in case that happens. You want to decrease any data loss like that. And really just making sure there's no bottlenecks in your code. You know, you don't want one step of your pipeline that's taking an abnormally long amount of time. You just want to make sure it's as efficient as possible. So now I'm just going to wrap up and talk a little bit about the benefits or why we should bother with these data pipelines. The first one is the improved data quality and accuracy. So I think anyone who works in data will tell you that the most frustrating thing is data quality. I don't think I've ever been handed a data set on a project day one and I'm like, this is perfect. That never happens. It's always a bit of a disaster. And trying to process that just takes so much time and energy, and your time could be better spent doing other things. So having a data pipeline that already does that and your data is good to go, it's great. The second one is flexibility and agility. So with data pipelines, they're super customizable to whatever your business ask is. You really have that freedom to mold it as you like. And if your business ask changes or your data source changes or anything like that, you have the freedom to change your data pipeline as well. So it gives you that flexibility. Number 3 is faster integration. So if you're wanting to integrate a new data source or something like that, if you were doing this manually, it could take a long, long time. But if your pipeline's there, it's generic and most of it's automated, it could be as simple as, again, inputting a few new parameters. So it's really fast to integrate new data sources. And the last one I'm going to talk about is scalability. So like I was saying, big data is so prevalent today. There's about 64 zettabytes of data in the world right now. I can't even comprehend a number that large. And about 90% of that was created in the last 2 years alone. So that's huge, and we need data pipelines that can handle big data. So I think some pipeline infrastructures may struggle with scalability, but I put this in as a benefit because I think with all the cloud technology we have today, we have access to on-demand compute power and the elasticity of the cloud. So any pipelines that are built and developed in the cloud should have that scalability factor that can handle large volumes of data. Thank you very much. I know it was very quick and I could definitely talk a lot longer, but hopefully you've learned something or got excited about data pipelines. But thank you. If anyone would like to ask me any questions or speak to me after in the break, please come ahead. But thank you.
That's great. Thank you very much, Anna. Great talk. Thank you.